What's up, guys? Here we go. We're going to continue section 7 and roll in here to section 8. So this video really is going to be on section 8, and it says statements of logic right there in the middle of the screen. But we're going to continue talking about these conditional statements where we have something written in the form of if, then. If P, then Q. If an angle is between 0 and 90, then it's acute. If an angle is 180 degrees, then it's a straight angle. Something like that, to that effect, that we're going to roll into. Now, funny little joke here for you. Check this out. It says, penguins are black and white. Nice little penguin. And then he says, wait, some old TV shows are black and white. So his logic that he could conclude from his understanding was, therefore, some penguins are old TV shows. Ha! Penguins are black and white. Some old TV shows are black and white. Therefore, some penguins are old TV shows. Well, as it says down here, the logic, another thing that penguins aren't very good at. Funny. Either way, doesn't matter, but it's a logic statement. We're going to talk a little bit more about what we can do with these conditional statements. So you already have this in class. We started this foldable flappy with deductive structure up here. Sorry, my screen only allows me to show this. You can barely see it. It says key vocabulary here in the bottom, which we did that in class. We're going to fill out this flap, this second one, third one, and fourth one on this video. So let's do it. So, the very first flap that you need to fill in right here, I actually moved this up, so I kind of cut off key vocabulary, which is underneath this flap right here. The very first thing that you need to put on here is this word negation, and what it means to take a particular statement, not a conditional statement, just a declarative statement, and negate it. And this, by the way, is your little symbol. So let me show you a couple examples of that. So what you see here on the screen is a simple statement that says, it's raining. Over here this says the angle is right angle. This one says the angle is acute. This one says this segment is not 4 centimeters. They're not conditional statements if you notice. They're just declarative statements. But here's how you take and negate these particular things. So if you would take this one, you would say it's raining. The negation of that is, whoops, sorry. It's not raining. It's that simple. This one over here, the angle is a right angle. The angle is not a right angle. That's what you're doing when you're negating these things. The angle is acute. The angle is not acute. The segment is not 4 centimeters. Then you would say the segment actually is 4 centimeters. So the negation is when you take something and just make it the negative of it. So if it's already negative or if it's already not, then you take it the positive, if you will. So, in general, though, here's the scoop. And you can write this on the front of your foldable. So if you have a declarative statement P, like we talked about in class, whatever it is, the negation of that is what we say not P. It looks like that. So this one would be if it's raining, it's not raining. If it's an acute angle, it's not an acute angle. If I'm not cool, then I am cool. That's the negation of a particular statement. All right? So now what I would do, again, if I was you, I don't know if you did this or not, but up here where it says negation, I would write this P right there, and then over here I'd write not P. So there's your example for that. Okay, so what comes next? Well, what comes next is this. You got negation. The next thing that you'd have is something called converse. So you can write that in your foldable flap right there. And here's the thing. The first thing that I want you to think about with converse is, well, what comes to mind? For me, converse is this. It's a shoe. Very true. But how I want you to think about converse is this. When you converse back and forth with someone, when you talk back and forth to someone. But I want you to think of this word converse not quite like a Converse shoe, more like a flip-flap. So you're going back and forth, flip-flap, 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 conversation back and forth, back and forth, back and forth. Because when you take the converse of a conditional statement, the converse of a conditional statement is when you just flip-flop things. So, let me show you a specific example. So you see this example now on your screen. It says, if an angle is 90 degrees, then it is a right angle. That is exactly a conditional statement. This, remember, is your hypothesis. This right here is your conclusion. Wonderful. So this is the P implying the Q. Now, a converse statement, if you start with something like P implies Q, the converse of this statement is just when you flip-flop the hypothesis and the conclusion. So it looks just like that. So I'm not going to write this down. You need to, though, but here's how you would take the converse of this particular statement. It would say, if an angle is a right angle, then the angle is 90 degrees. So that's the converse. It's when you take and flip-flop the P and the Q. Okay, so we got negation. When you negate something, make it not this or negate that, or you converse, you flip-flop. So next thing then is this. You can take a conditional statement and do what we call the inverse. You can inverse a conditional statement. So we got converse, which is a flip-flop. Inverse is a little bit different. So let's do that one. So inverse is this. If the original, again, statement or implication is P implies Q, the inverse is you keep the order the same, but you just negate the first thing, so make it not P, implying not Q. So you just negate this this conclusion, and you negate the actual hypothesis, just keep them in the same order. So again, I'm not going to write this, but you need to. Here's what the wording of the inverse of this green conditional statement would say. It would say, if an angle is not 90 degrees, then it is not a right angle. That's exactly what the wording would be for the inverse. So you just take those things and keep the order the same, but you just negate the first one and negate the second one. Okay? Awesome. Let's go to. So here's the three, and the last one is a very fun one to say. It sounds like an actual video game, but it's called this. It's called the contrapositive. So you got negation, converse, which is flip-flop, inverse, which is keep the order the same, but just negate the two. Beautiful. And then contrapositive is actually this. Follow my words. The contrapositive is actually the inverse of the converse. I'll say it again. The contrapositive actually is the inverse of the converse. So let's go to this example and see if you got it. The inverse of the converse. So the contrapositive, if we have P implies Q, it is the inverse of the converse. So I must first take the converse. That means I take Q and P and flip-flop them. So I take the converse first, and then I take the inverse of that. So it's this. It's not Q implies not P. So I'm not going to write this. You need to write it though. Here would be the exact wording of this conditional statement if I took the contrapositive of it. It would say, if an angle is not a right angle, then the angle is not 90 degrees. If an angle is not right, then it is not 90 degrees. That is the contrapositive. So we got converse, inverse, contrapositive, and negation. And then we're going to talk about whether these things are true or false, because that leads into a huge discussion whether these things are right or they are not right. Because you can converse anything, you can inverse anything, you can contrapositive anything, but that doesn't mean they're still true. Alright guys, last thing, and on the back of the foldable, so flip the foldable over, write chain of reasoning on the very back of it, and here's the example that we're going to do. So if we have some type of a conditional statement, an implication where P implies Q, and it is true, we know for a fact it's a true implication, a true conditional statement, and at the same time we also know this thing Q implies something that's R, whatever that is. But then at the same time, we also know another implication, R implies Z. If we can and know for a fact that all three of these implications are true, so there's no, chink in the chain for any reason, there's no, break in the chain. It is exactly P implies Q, Q implies R, R implies Z. The ultimate question, ladies and gentlemen, is what can you conclude? What do you think? I'll give you a little hint. Back to Algebra 1. If you linked all of these things together, it would be called the transitive property if P equaled Q, Q equaled R, R equaled Z. You would conclude that P would be equal to Z. And that is an accurate thing from Algebra 1. By the way, same thing happens with the chain of reasoning with logical statements, implications. So if P implies Q, Q implies R, R implies Z, then ultimately you could conclude that P would then imply Z. So P, the whole way through all of these, would imply Z. Now, here comes your checkpoint question. I'm going to give you a video. I'm going to play a video here for you. And this video is a YouTube video. It's from a commercial that's been on TV for a long time, not recently, but it's a direct TV commercial. I'm not condoning direct TV. I'm not saying you should get it. Doesn't matter. It's just an unbelievably awesome example of chain of reasoning. And there's a bunch of these. I'm just going to show you one. And what I need you to do, you might need to listen to it a couple times, but I want you to do exactly what I just did here on this screen, where if it starts somewhere, the whole commercial starts with something happening. It goes through a whole bunch of chain of events, and then it ends with something. So you'll see how one leads to another, leads to another, leads to another, leads to another, and you can conclude, ultimately, something. If something happens, then the whole way through the video, then this will happen. That's what I want you to respond in your Google form as your checkpoint question. So enjoy and go watch the other ones. Don't waste a lot of time on YouTube, though, because you sure can, and we'll see you guys in class later. So here is the actually, you know what? Hold on. I need to do this. It doesn't play on my computer. I'm going to show you where to go. So hold on a second. So here you go. When you type into YouTube, here's what you need to type. Direct, or go to YouTube. Type in direct TV commercial, and then put stray animals. And spell the right matter. There you go. And then the very first one that comes up, this one right here, is the one that you need to watch. So when you click on that, it's only 32 seconds. It's a short little commercial, but you need to watch it. And there's a bunch of other ones too. You can see if you just type in direct TV commercial. Watch a couple other ones if you want to, but it's really cool. Again, I'm not condoning direct TV, but watch the stray animals commercial and you'll see this chain of reasoning. See you guys in class. Later.